Laura buys a pack of 24 blueberry muffins that has a total of 1,536 calories. Okay? Okay. What is her calorie intake if she ate 3 muffins? Which are my favorite? Blueberry. Costco blueberry muffins, the best. Maybe the best. Okay, so Laura buys a pack of 24 blueberry muffins that has a total of 1,536 calories. What is her calorie intake if she ate 3 muffins? Okay, so the two things we're talking about in this problem are muffins and calories, right? Well, the first thing I'm going to ask you, there is a question already in here that says, well, how many calories in 3 muffins, right? But before we answer that question, I want to know, what is the constant of proportionality? Meaning, what is K equal to in this problem? So we're not going to answer just yet the 3 muffins part. I want to know, because it's going to help me figure out the 3 muffins. I want to know how many calories per muffin. I want to know how many calories per muffin. So what is the constant of proportionality in this problem? If I ignore this part, right? If I ignore that part, I'm not going to worry about that question right there. So knowing that Laura buys a pack of 24 blueberry muffins that has a total of 1,536 calories. So 24 have 1,536. But I want to know, what's the constant of proportionality? How many calories does one muffin have? One muffin, not 24 muffins. I already know what 24 muffins is. I want to know how many calories is one muffin. So let's divide this out. Let's grab a calculator for sure. 1,536 divided by 24. So plug this number inside your calculator first, please, and let me know what you get. Yes, 64. What does that mean? 64 what? 64 muffins or 64 calories? 64 muffins or 64 calories? What did we just solve for? So K is 64 muffins or calories? Muffins or calories? Correct answer is calories. So we have 64, yes, thank you, Belen, 64 calories per muffin, okay? So question number 2. How many calories in 3 muffins? How many calories in 3 muffins? Now we can answer the question they gave us. So we have 64 calories per muffin, right? Per 1 muffin. But the question is, well, how many do you have in 3 muffins? Each of them has 64. How many in 3 muffins? 3 muffins. Grab those calculators. How many calories would 3 muffins have? 3 muffins. Yes, yes, yes. Thank you, thank you, thank you. How many? So 192 calories. How do we get that? 64 times 3. 64 times 3 is 192. So how many calories in 3 muffins? 192. Perfect. Now, like I said, they can take one question and ask you 1,000 things. So here I am asking you 1,000 things for one question. So we're still talking about Laura and her 24 muffins, okay? What is the equation? What is the equation? What equation do we write for this problem? I'll give you a clue. It starts with y. What equation is represented in this problem? It starts with the y. What equation is written for this problem? Starts with y. We did this on last Wednesday. Oh, gotta use the unit rate. Gotta use the unit rate. The 192 is for 3 muffins. The unit to write your equation, you have to use the magical number of k. So our equation would be y equals 64x. That would be the equation. Y equals 64x. Why 64? Yes, don't forget the x. Don't forget the x. Why 64? Because 64 is your unit rate. So we use this number to build our equation. We use this number to build our equation. Okay. Okay, I'm gonna want you to build a table now, but I gotta turn the page. Now, if you have room, please do the table in here, but I kind of ran out of space. I'll turn my page, my very last page in my notebook. Oh, no. So here is number 4. Oops. Create a table. X and Y. X is muffins. Y is calories. Okay? X is muffins, Y is calories. 0 muffins, 1, 2, 3. So this is how we create a table. If I ate 0 muffins, if I have no muffins in the house, how many calories is that? 0 muffins. 0 muffins is 0 calories. How many calories does 1 muffin have? 1 muffin, if I go back, right there, per muffin, 64 calories per muffin. So 1 muffin is 64. How would I get 2 muffins? Well, from here to here, I'm just going to add 64. So what's 64 plus 64? Yep, 128. Thank you. And 3 muffins, how much would 3 muffins cost? Well, we already did that. How many calories does 3 muffins have? 192. So you can just plug it in here. 192. So 0 muffins is 0 calories. 1 muffin is 64. 2 is 128. 3 is 192. The last thing you're going to do is you're going to graph it. Now you already did all of the hard work. Now graphing is actually the easiest part. So we're going to do This is your X. This is your Y. X represents muffins. Y represents calories. Right? And when we number the lines. 1, 2, 3, 4, 5, 6, 7, 8, right? And calories, because you're drawing your graph, you're creating this graph, on the Y, I would go up by your unit rate, which again, you already did the work, right? So the first line right here is 64, because this one's 0. This is 128. This is 192. 256, if I did the math correctly. Let me see. 192 plus 64. Yep, plus 64 is 320. Plus 64, 384. All right, so the first point is this one. Okay, Armando. So 0, 0, 164, 2, 128, 3, 192, 4, so on and so forth, right? And when we connect them, I want to make sure we're going to connect it to 0, 0. Just like that. Okay. So this is your graph, your table, your equation. You answered a question. You told me what the constant of proportionality is. And there's like other things I can ask you, which I will. I will be asking you this as the days go on. So important for today, you're going to be answering questions like this, where it's about expanding on this, okay? So let's do one more. Let's do like a faster one. Oh, I need a new notebook. Okay, let's see. Quick. I ran 3 miles in 30 minutes. How many miles did I run in 50 minutes? Okay, let's do this one. Should be fast. I ran 3 miles in 30 minutes. Nice, easy pace, guys. If you're in Run Strong, I'm pretty sure you run faster than me. How many miles did I run in 50 minutes? I mean, if I can run 3 miles in 30 minutes, I would be proud of myself. You know. Yeah. Okay. So first thing I want you to do is, what is the constant of proportionality? What is K equal to? Constant of proportionality. How many minutes did it take me to run 1 mile? How many minutes per mile? How many minutes per mile? So if I divide this, 30 divided by 3, I get 10. So that means it's 10 minutes per mile. A 10-minute mile. That's not bad, right? So each mile, it takes me 10 minutes. 1 mile, 10 minutes. 2 miles, if it's a constant rate, 20 minutes. 3 miles, 30 minutes, right? So how long does it take me to run 50 miles? Or I'm sorry, how many miles did I run in 50 minutes? How many? So let's write that down. How many miles did I run in 50 minutes? How many miles did I run in 50 minutes? Uh-oh. Can you guys hear me? Hello? Testing, testing. Can I get some feedback? Can you guys hear me?
I can hear you.
Yeah? Okay. Because I've had 2 students tell me they can't hear me. So, but you guys can. Okay. Am I quiet? Or am I okay? Volume okay?
Okay.
Okay, okay. Un momento. Okay. How many miles did I run in 50 minutes? So how many miles did I run? How many miles in 50 minutes? So I ran 5 miles in 50 minutes, right? Because I know that 1 mile is 10 minutes, right? So if I have 50 minutes, what did I do? I just multiplied by 5. All right, so what's my equation? What's my equation? Yay. Okay, so what's my equation? What would be my equation? What would be my equation? Take your unit rate. So your unit rate is 10. So we take this part and we're going to use it for our equation. Y equals 10x. Y equals 10x. All right, let's do the table and the graph. X, Y. X is mile, and Y is time, minutes. Oops. So 0, 1, 2, 3. So if I run 0 miles, it's going to take me 0 minutes. I like that. If I do 1 mile, it's going to take me 10 minutes. If I do 2 miles, 2 miles is going to take me 20. 3 miles is going to take me 30. What do I keep adding by? I keep adding 10 each time. Keep adding 10 each time. I'm going to graph it. This is Y. This is X. X is miles. And this is time. So 1 mile, 2, 3, 4, 10, 20, 30, 40. So 0, 0. That's like the second most important dot, the 0, 0. Some of you on your notes in classwork last week, you guys did not graph 0, 0. It's the second most important dot there is. So make sure that you have a dot on 0, 0. Make sure you connect your graph. Connect your graph. Okay, don't just plot points, but we're connecting. We're making a nice, pretty straight line.